Hey guys, what's up? We're going to look at parabolic motion. Now, parabolic motion is actually something you come across all the time in your everyday life. Whenever you throw an object, the shape of the path that object will follow will always be a parabola. It's easier seen with something like a football or a basketball, and if you look side on, you'll see this parabolic shape traced out. If you throw a pen, the pen spins, so it's a little bit more difficult to see. But if you were to trace the center of mass of that pen spinning around it, it would trace out this parabolic path. So the first thing to note is that whenever something is thrown within a gravitational field, the shape of the path is always known as a parabola, and we call it parabolic motion. Whenever we talk about motion and the mechanics of something moving, we need to understand what forces are acting. And we're considering the forces after this ball or this object has been thrown. And the only force acting in this case is going to be weight. We're not going to call it gravity because gravity is the force that acts upon a mass to create the weight. And weight always acts vertically down. And it's really easy, one mark answer saying what's the only force acting on this object throughout the parabola, and it's the object's weight. And it always acts, wherever that ball is in this path, it's always acting vertically down. We're going to ignore drag. We're going to say there's no drag or air resistance. Therefore, there's no horizontal forces. And this is really important because it simplifies our problem. And it means that we can assume that the horizontal speed is actually going to be constant. The secret to understanding parabolic motion is understanding these two things. Weight acts vertically down and there's no drag. And we can separate the motion of this object into vertical and horizontal components. And these are actually independent of each other. So let's have a look what I mean by that. So here's an object. This is a ball that's been thrown and it follows this parabola, or it follows a parabolic path. And we said weight's the only force acting vertically down and there's no drag or air resistance. It's thrown with a speed v. That's its overall speed. And it's acting at an angle theta to the horizontal. We don't like vectors at angles to things. We like, as physicists, to simplify problems. So we're going to separate this overall velocity of this ball into two dimensions. We're going to look at the horizontal component, VH. That stands for vertical velocity in the horizontal direction, and VV, which is the vertical component of the velocity. And if you remember about how to resolve vectors, the horizontal component is V cos theta. I always remember that because I'm going across the angle, so it's cos theta, and the vertical component is going to be V sine theta. And as I've mentioned, there is no drag acting. So this horizontal component is constant. Wherever you are in the flight of this path on the parabola, the horizontal component will always be the same. It is constant. So VH, really important, is constant. I can't emphasize that enough, and that's because there's no horizontal forces acting. So at every single point, wherever you are, it will be exactly the same. But there is one other force acting, and it's weight. And we've said that it acts vertically down. And that's going to have an effect upon this vertical component of the velocity. As the ball follows the parabolic path, the vertical component is going to get smaller and smaller until at the top, V vertical, the vertical component of velocity is actually zero. The ball can't get any higher. It's at its highest point, so it can't have any more velocity in the upwards direction. Past this point, it starts to gain a negative velocity because weight is causing it to accelerate in the negative direction. There's a little bit of symmetry here, and at the end, it ends with minus V sine theta. The vertical component is the negative of what it started off at. The horizontal component is unchanging. Symmetry is really important when you solve parabolic motion questions, and I'll do another video about how we can actually do calculations using parabolic motion. But the time it takes to get halfway, so if this took a time t, it will take a time t to do the second half of its flight. Really important. That symmetry is really, really, really useful. So in summary, weight's the only force acting and it's vertically down. Therefore, the vertical component is changing. But because there's no horizontal forces, there's no drag, the horizontal component is constant. And we're always going to look at these two components, the vertical and the horizontal components, separately. They're independent of each other. This next image shows why the ball follows a parabolic path. As you can see, the horizontal component is unchanging. V cos theta is the same at all points. The vertical component, VV, gets smaller and smaller and smaller until at the top it's 0. Then it starts to become negative. And it ends with the same magnitude as what it started. So this is minus V sine theta. Why it follows a parabola is the resultant velocity. If you were to combine these two components here, for example, you get this resultant velocity V. If you combine it here, we get the resultant velocity here. So the ball traces out a path that is traced out by the direction of this resultant velocity vector. One other point to note, and I've seen it on an exam question, it says, why does the ball still have kinetic energy at the top of its parabola? It's not moving up vertically, but it has still got this horizontal component. Really important to remember that. So it's still moving, it's still got kinetic energy because it's still got its horizontal velocity. So this is why it follows a parabolic path, and every single object will do that. So in summary, key facts to remember. The shape of this motion is parabolic. So we say that the shape of this is a parabola. We call it parabolic motion. The reasons for this is the fact that we've only got one force acting. Weight is the only force and it acts vertically down. That causes the vertical component of the velocity to vary throughout the parabola. We always assume that there's no drag. So the horizontal component of velocity is constant. It is unchanging throughout the flight, and that makes the problem so much easier to solve. Remember your symmetry, that the time it takes to get to the top is equal to the time it takes to fall down to the ground again. And if it starts on the ground and lands on the ground over here, the vertical component of the velocity is going to be the negative of what it started off at, minus V sine theta. So, parabolic motion. This is just the basics. We're going to look at how to solve problems in another video, but it's really important to remember all of these key facts because it will enable you to solve it. And the last important point is the fact that the horizontal and the vertical components are independent. They act separately to each other. That's it. Thanks for listening. See you all soon.